Alright, Chapter 5, 3D Primitives and Conversions. Autodesk AutoCAD 2013 Practical 3D Drafting and Design. Alright, Chapter 5, 3D Primitives and the Conversion. In the previous chapter, we saw the creation of the derivative based on the layer of the objects. In the current chapter, we will see the remaining commands of the create 3D, solve 3D, surfaces, solve with the conversion commands. Topics covered in this chapter is solve with 3D, solve basic shapes, create planar surfaces, create planar surfaces, delineated linear objects, convert objects to solids, convert objects to surfaces. 3D solids primitive, but the primitives solve the basic shapes of the boxes, cylinder shapes, and spheres and others. We can also apply a special solid primitive to create walls in similar ways as created as a polyline. Accessing all these commands beside the digitizing the name LS can be done by the ribbon home modeling panel, modeling toolbar, and the draw modeling menu bar. As you can see, the home drawing menu polysolids. The creation of these solid primitives list most of the commands in the previous chapter of the dynamic even compounds specification. One or more important the dimension we see with the objects being formed. Note, for the most basic shape, with the exception of the polysolid, we can use the property select the palette Control +1 and change the dimension parameter for creating the solid. Improve the visibility curve face with the non-wireframe visibility styles. Will apply with the face facet resolution variable. The value of the 2 or 3 normal enough. The wireframe visuality styles may apply with the ISO line variable. The increment with the number of lines used with the represent of the curve face. The dispatch display silhouette variable. To show a silhouette profile line solids curve face, the variable that will explain at the end of chapter 4, creating solids surfaces with a 2D from 2D. Creating boxes and wedges. We show the most basic 3D shape of the box. The wedges are boxes cut into two, and dialogues are options. Wedges are boxes cut into two. Dialogue options are exactly the same. The box command. Box command creates a box thus the solid with 6 rectangular orthogonal faces aligned with axis current user coordinating system. The default command asks the first corner, the opposite corner. Commands first corner, opposite corner, cube in length and point. 2 points must not. These 2 points must not be on the same axis as they may be defined. The area of these 2 points of the same plane. The height is requested specified with the next value of the created downward specified with the height or 2 point value. No, the easiest way to create a box is specify the first corner, define the opposite corner relative to the corners of the 3 directions at length, width, and height. Options of the command with the center. Instead of specifying the first corner, we can start with defining the center of the box. Then we define the other corner of the option. The cube to define with the first corner center of the option allows you to create with the cube required for the cube length. If we pick a point, the cube may be rotated length after defining first corner and center of the option allows you to specify the length along the x-axis and along y-axis, height along the z-axis of the box. In order to pick point specify the length of the box may be rotated to 2 point. The length of the height of the box can be defined by specifying 2 points. The wedge command alias WE creates a wedge box cut with a diagonal plane with a triangular face with a planar panel of the ZX plane. The dialog edge box command, the default will be specified with the 2 corners, wedge, first corner or center point, other corner, cube in length point. These points are the same plane. Height is requested. The inclined face of the plane points towards the x-axis, same height or 2 point of value. Option is this is centered. Center install options for this command. Center. Instead of specifying the first corner, we can start by defining the center of the wedge. Then we define the other corners of the opposite options. Cube. We define the first corner center of the option allows you to create with half a cube by a diagonal plane. Request the cube length. And length defining first corner or center of this option allows you to specify the length along the x and along the y-axis and height along the z-axis of the wedge in this order. 2 point. The height of the wedge can be defined specifying 2 points. Alright, the practice of these objects we're going to create with the basic shape of the construct of the building similar to the cathedral. We start with a new drawing and create a layer called the 3D cathedral applied with the green color to make it a current with the create of the box with a length of 100 by width of 40 and the height of 45 of the first corner of the immediate origin opposite of the 140 and 45. We create another box whose center is in the middle of the top of the face. We specify the center option of the O-track function. Aim at finding the center over the top of the face. Another way of the center is to apply the individual 3D O-snap center of the face. Control mouse right click with the opposite corner. Aim at 15 to 15 by 20. Later we will combine these boxes again, and the boxes will create with one tower of the dimension 10, 10, 30 at one of the top corners. We copy the last block with the top to the other of the top of the corner. Now it's time to create two wedges at the edge of the kind of the buttress. We apply with the wedge first to the left of the corner of the box. The dimensions are 25 and 40. We create another wedge in the same first corner with the dimension 15 and 15 and 30. If the box wedge is orientated to X, we'll apply with the rotate command to rotate them around the first corner to rotate 90 degrees. Later we'll subtract the second of the first wedge. We copy these two wedges twice to have one set of the middle of the edge of the other end. Finally, they mirror the 6 wedges of the other side of the building. 11 and later we will continue, and for now save the drawing as A3D0501 final drawing. Creating cylinders and cones. The next two 3D basic shapes we are going to see are the cylinders and cones. Cylinder command. Cylinder command is alias CYL. Creates cylinders with circular elliptical circular elliptical bases. This is solids with two planar circular elliptical faces and one curved face. By default, the command starts prompting center of the base and of the radius of the default. The command center is the center of the base of the 3.2 point tangent radius elliptical, and then at either point the base to the center of the point. So specify the base point, radius, or diameter value of the point. Next, we specify the height of the cylinder, specify the height, 2-point axis, endpoint value, or point. Cylinder command has the following option: 3P, 2P, or 3.2 point or tangent radius. These options are identical options for the circle command. Thus, the allowing the defining the base circle with the 3 point, with the 2 point, with the diameter tangent with the two existing objects, specifying the radius and respectively. Elliptical. This allows you to define an elliptical base with a cylinder with the same optional ellipse command. By default, the prompt the 2 points with the define with the first axis, with the define with the second semi-axis, with the center with the option define with the elliptical base starting with the center diameter instead of the defining with the radius of the base. The option allows you to specify the diameter 2 point, allows you to define the height of the cylinder by 2 points, and axis endpoint allows you to specify the position of the center of the top face of the cylinder. Axis defined with 2 centers that are not parallel to the z-axis current user coordinate system, both linear faces, and the rotate with the same perpendicular on the cylindrical axis. No, the axis endpoint option allows us to create cylinders and bases not aligned to the current XY work plane that may be avoided its creation of a specific user coordinate system. Alright, the cone command. The cone command, no alias, allows you to create cones and true frustum cones. In the first case, the object is composed with a curved face, planar face, and second with the case with the two planar faces with a curved face. By default, the command prompts the center, base, and radius. The command cone, center, and base, and radius, 3.2 point tangent radius, elliptical point, and then you choose your point, specify the base radius or diameter with a value or point. Next, we have to specify the height of the cone, or 2-point axis, endpoint, top radius value, and given the value of the radius or point. Most of these options are similar to the cylinder cone. Cylinder command, these are the 12 with 3-point, 2-point tangent radius. These options are identical options, but the circle command allows you to define the base of the circle 3 point, 2 points with the diameter tangent to two existing objects, specified radius respectively. Elliptical allows you to define elliptical base of the cone with the same option elliptical command, but default prompt with the 2 points with the define with the first axis into the second semi-axis with the center option defined with the elliptical base with the starting of the center. Diameter instead of the defining of the radius of the base of the option allows us to specify the diameter. 2 points allows us to define the height of the cone by 2 points. Axis endpoint option allows you to specify the position of the top vertex of the cone. The cone axis if it's not parallel to the z-axis of the current user coordinate system. The cone is rotated the top radius of the option. We're prompt for the radius of the top face if it's not 0. If then create for the frustum cone. Alright, exercise 5.2. Now we continue exercise 5.2. Let's open the drawing starting at, say, with exercise 5.1, A3D0502 drawing. We create the first cylinder with the center of the base, with the middle, with the top of the face, with the higher box, with the sheathing O track, with the midpoint, with the 3D O snap center of the face, with the radius of 13 and the height of 2. Continuing with the model with the part of the building, we create with the new cylinder, edge with the center of the base, with the center of the top face of the previous cylinder, and a radius of 8 and the height of 10. To create the columns again with the use of the cylinders with a center of the 180 degrees quadrant with the top of the face of the first cylinder with a radius of 0.8 and a height of 10. We move the cylinders inward by 1, and this is the that's in the X direction. Then show the picture. We apply the array command with the choose the polar option center over the array with the center of the first cylinder with the define 16 items filling with the angle of the 360 degrees cap of the first cylinder 12 meters along the Z direction. Alright, on the back of the building we create another cylinder with the center of the midpoint, lower edge with the radius of the 10 and the height of 30. On the top of the cylinder we create with the cone of the same radius with the height of the 15. We save the drawing as A3D0502 final drawing, creating a sphere and another basic shape of the sphere and globe created with the next command. The sphere command in OLS creates the sphere with the 3D shape that has only one curve of the face, while all the points of the face are the same distance with the center of the no edge of the vertex. With the default command prompts the center of the sphere, the radius sphere, the center of the point, 3.2 point, tangent, radius, point, space, strip of the radius or diameter and value or point, and then show the sphere of the option, similar to the previous command. Your 3.2 point and tangent, radius. We define the circumference of the sphere with a 3 point, with a 2 point, with on a diameter or tangent with the two existing objects. Specified with the radius, the diameter, instead of defining the radius of the sphere. With this option allows us to use specify with the diameter. Note, the wireframe visual styles of the sphere shows only the two meridians and three parallel iso lines. We may increase the value of the iso lines variable with the shaded visual style with the render. We get the best result with increasing the value of the facet resolution variable. Creating 3D donuts. If you want a solid shape of the like a donut with the torus with the next command with the possibility of the shape of the obtained with applying with the revolve command of the circle with the create torus command with the torus command with the all alias of the TOR creates torus solids with the solid with the 3D donut shape. By default with the command prompt with the center with the torus with the radius with the torus with the radius with the circular section with the torus bisect with the explain with the current user with the coordinate system. As you can see, the command would be a torus zone specify the center point of 3 point and 2 point or tangent radius, or as a point, specify the radius or diameter value or point, specify the tube radius of the second point or the diameter value of the point. Beside 3D donut shape, we have the torus radius greater than the section radius with the solid perimeter associated with the two particular shapes. The apple shape and the torus radius is smaller than the section radius. Rugby American football shape, torus radius is negative and with the absolute value smaller than the section radius. The option with the command with the 3.2 point tangent radius. We define circumference of the free torus of the 3 points with the 2 point with the diameter of the tangent with the two existing objects with the specified radius. Diameter inside with the defining radius of the torus. The option allows us to specify with the diameter. 2 point, the radius of the circle section should be defined by 2 points. The exercise of 5.3. We are placing some of the elements for the into our cathedral. Opening a drawing, say with the exercise 5.2 with the A3D0503 drawing. Create the sphere with the top highest cylinder with the center of the coincident with the center of the top face with the radius of the 13. This is also be reached by the quadrant point. Later we will cut the sphere in half, forming a dome. Apply the user coordinate system command. Create the coordinate system aligned with the front of the facet with the origin left lower corner. First block with the X's defined with the other lower corner. XY plan to define with the top of the corner with the face of the user coordinate system allows with the control of the precise position of the torus. Play with the torus command players with the midpoint with the lower edge with the point along the Y right 30. The O track function must be on. Another way to specify the torus origin is 2030 absolute coordinates of the radius of the torus by is 11. The radius of the section is 1.5. Activate the world coordinate system for instance with the default option of the US coordinate command. Save the drawing as 03 A3D0503 final drawing. Creating pyramids. Next, in the command with the grading pyramids, the pyramid frustrum with the regular base for the pyramid command with the pyramid command, also alias PYR, allows you to create the pyramid with the base for the regular polygon side with the equal side with the possible to create with the pyramid frustrum with the default with the command with the display the information about the current setting of the base for the prompt for the surround of the base. Command pyramid, four-side circumscribed, specify the center of the base of the point, or edge is the side or point next to specify the radius of the regular polygon to define the base of the pyramid in accordance with the display with the options specify the base of the radius and inscribe value point. Finally, we specify the height of the pyramid, specify with the 2-point axis for the endpoint with the top radius value of the point. The options available for this command over the edge of the instead of the center of the radius varies by the specify the 2-point with the define one side of the base pyramid is similar to the option with the polygon command. Sides allows you to change the number of sides of the polygon that is described at the base of the pyramid. Inscribe, circumscribe the polygon to define with the base of the pyramid. It can be inscribed with the radius to define with the distance vertices of the circumscribe with the radius to find distance to midpoints. Choose the side 6 edged and circumscribed, inscribed. 2-point allows you the height of the pyramid is by 2-point with the axis. Endpoint allows you the position of the top vertex pyramid. The pyramid axis with the normal, not paired with the z-axis with the current user coordinate system. The pyramid is rotated. Top radius the option prompt for the radius for the top face if it's not 0. They create the pyramid frustrum. Axis endpoint axis top radius. Creating walls. Last 3D solid primitive allows you to create some of the kinds of the wall with a different with extrude some kind of walls in a different way from extruding and press pull commands. The polysolid commands are p-solid, too long to be an alias, allows you to create some of the solid similar to the walls. With a command really does it take the wall section and apply with the sweeps to a long path defined by the use of the path can there have several segments action construction similar to the drawing of the 2D polyline. Note, this is the only primitive that we change with the properties palette. The object that recognizes the sweep solid if it was created with the sweep command. By default, the command is displayed with the information by the height, width, and justification just prompt at this point. Command height, width, and justification center. Specify the start point, object height, width, justification object, and then give the point. Specify the next point or arc undo, and a point. Specify the next point, arc undo. If you want to draw the wall along the arc, we apply the arc option. Specify the next point over the arc, and specify the end of the arc, and a closed direction line or second point and then pointed to the point. To return to the segments, we apply the line option, specify endpoint with a closed direction line, second point until the line, specify the next point, arc close or undo, and then the points around. To end the command, we just press enter, specify the next point, and arc close or enter and end. This command has the following option. Object prompts the selection of linear object applied with the object for the path of the deleted object variable to control the object at the race. The legible objects are line are arcing cycles or 2D polylines. Height. With the option control of the height of the wall section with control of the width of the wall section. Justify except the left center with the right justification control of the point. We specify the define the path corresponding to the left face center of the wall and the right face. So the left width, left center, right. Close and undo when specified with the close option closes the wall, but the undo option cancels the last point like a plot p-line command. Arc line when specifying arc change the mode for the arc to add arcs to the path. My default arc continue with additional option the direction. Second point allowing directional changes. Line changes back to mode line. No, for complex path, it is better to draw 2D polyline than apply with the object for the option. Exercise 5.4, when continuing the exercise of the application of the pyramid, the wall performing the following steps. Open the drawing, save the exercise 5.3, A3D 04 drawing on the top one of the tower with the supply with the pyramid command with the edge option spec for the two sides with the corner with a height of 15. Copy the pyramid to the other tower. Finally, we're going to build a small wall at the top largest box with apply with the polysolid command. Change the height of 1.2 units, width of 0.2 widths, and justify to the right, we specify the points counterclockwise. Save the drawing number A3D 0504 final drawing. Alright, primitive surfaces. In the previous chapter, we explained how to create surfaces of linear object with extrude, revolve, swift. Law of commands these present with a command with a create regular rectangular surface with a defined by planar objects. creating a planar surface. This command with the created planar surface, the planar surface, the command with the planar surface, the command no alias creates a planar surface defined by the two options of the corner of the delimited by one or more existing objects of the default with the command line. Just prompt the two options of the corners created with a rectangular surface, the command plan surface, first corner object or object at point, and the specify the other corner and by, and the command has only one option is object. So we're looking at the circle of the linear arcs 3D face in the regions, and that's the object, the planned surface. Object prompts of these sections, and we select the, so once again that is the planned surface. The 3D, the option promotes the selection of objects. We can select line, arcs, circles, ellipses, the 2D polylines, 3D polylines, planar splines, regions, 3D faces. For each closed object, the set of objects should form a closed boundary with the option created the surface of the default with the original object and maintained in the drawing. Note, there are two important variables to creating the surface of the other object. The surface associativity controls the surface that remains connected with the original object, the value 1, not its value of 0. The variable is saved within the drawing with the value of 1. The deleted object variable to save with the Autocad is not applied with the surface to end of all original object with not delete the original object creating surface associated must be 0, and the delete object must be 1. Delete object is 3. Default, the original objects are not deleted. In several situations, the 3D face command can be used instead of the plane surface of the command with the present of the chapter 12 of the mesh and surface is created with the planar face out only specify 3 and 4 corners. The advantage of the application of that we can stress the end corner even with the grip of the end corners of anywhere within the 3D independent with the current user current coordinate system. For instance, we can create a vertical face easily to simulate with the door and window. These faces can be converted to surfaces within the plane surface command. Alright, conversion between 3D objects. There are two commands that convert with the solid surface to include with the creation of the profit. The commands can be filed with a menu board modified for 3D operation on home with the home solid editing. Convert object to solid. These commands convert the some type of the objects to solids. The convert to solid command, no alias, converts to the following objects as 2D polylines uniform with a non-zero thickness, 2D closed polylines with a non-zero thickness, circles with a non-zero thickness, closed surfaces without openings between edges, and closed 3D meshes without opening between edges. The command just prompts the selection or the deleted object variable with the value 1 indicates the deletion of the original object. Note, the converted solid maintain layer, color, and general properties from the original object. The current layer is not applied. And that was converting solid to solid. Converting objects to surface. The next command converts with the same type of the object as surface. The convert to surface command. Convert to surface command and converts with the following objects to surface. 2D open polylines non-zero thickness. Line arcs non-zero thickness. Region planar 2D faces 2D solids versus solid command 3D solids and 3D meshes. The command just prompts the selection of the delete object with the value of the 1 to indicate the deletion of the original objects. So that's going in from conversion to surface. This converted for a surface is maintained layer, color, and general properties from the original object. The current layer is not applied. Some of this chapter included all 3D basic shape, 3D primitives along with the construction of the simple 3D model presented of the box, wedge, cylinder, cone, sphere, torus, pyramid, poly, solid. Commands also include the planar surface, the command creating planar surface, the two commands converting existing geometry to solids, the convert to solid and convert to surface. In the next chapter, we will also see the general 3D editing commands, commands specifying solid surfaces if it's presented in the chapter 7, and editing solids and surfaces. Chapter 6, Editing in 3D.